Good day, my darling students. You are welcome again to another darling program. That is, of course, your program you've been waiting to see. That is Mathematics and School on Air. In the previous episode, as usual, time wasn't our friend. We started trying to look at lines of latitude and longitude, how we could use them to determine the location of places on the Earth's surface. In particular, we used Lagos, a city in Nigeria, as a reference. That was in longitude 4 degrees north and of course 3 degrees east. And then we went further trying to locate some other position on the Earth's surface. So today we shall continue on those ones. So today we shall actually start by looking at angular differences between places on the Earth's surface. Angular differences between places on the Earth's surface. Okay. In the previous episode, we saw the angle that each position on the Earth's surface subtend at the center of the circle, that is at the equator. And so when we have two positions on the Earth's surface and each one of them subtending different angle from the equator, then there is a need for us to determine the difference, the angular difference, and that for us to be able to determine what is even their distance apart on the Earth. So we have to start looking at that. How do we determine? So we say the angle subtended at the center of the great or small circle by the minor arc formed by joining two places on the great or small circle respectively is known as the angular difference between the two places on the Earth. So when you have two positions on the Earth's surface and each one of them is drawn to the center of the circle, each one of them subtends a different angle. So when it is joined, then the angular difference, the angle that is made as a result of joining the two arcs, of course, to the center of the circle, is what we call the angular difference of the two positions on the Earth's surface. So at this level, actually, we are going to be limited to angular differences involving places usually along the same longitude or along the same latitude. In other words, we are trying to say that we are actually going to be looking at finding angular differences between places that perhaps either have the same latitude and different longitude, or they have different longitudes and then the same latitudes. So at this point, so that's what we are going to be looking at today. All right, so we're going to take a look at an example. By the time we take some examples, we see how this can be illustrated and how this can be done. All right, so let's take a look at this example. This one is asking us to find the angular difference between the following pairs of places on the Earth's surface. So we are going to be given some places on the Earth's surface actually. So we're going to have to find their angular difference. Okay, so we have these problems to deal with. We have two positions on the two places on the Earth's surface. The first one there, we have point E 30 degrees north, 45 degrees east. That's the longitude. And now we have a position F with a latitude 25 degrees south and then longitude 45 degrees east. And then the second problem is having to find the angular distance between two positions G and H, 70 degrees north, that's defining the latitude, and then 35 degrees west longitude. And then the position H, of course, has its latitude defined as 40 degrees north, and then 35 degrees west of the Greenwich meridian. So we have to deal with finding the angular distances between those pairs of points. So let's proceed. All right. So how do we solve this kind of problem? So you go ahead by, of course, firstly drawing a sketch. Anyway, you're not a fine artist, okay? So you are not expected to give me something as neat as this, but all you need is a sketch to show, of course, different positions on the Earth's surface, okay? Of course, this is the polar axis, which is defining the Greenwich meridian. Okay, so we have the two positions defined here, E and F. All right, so the latitude is defined by 30 degrees north of the equator. So we have this. Okay, and then of course the longitude is defined by 45 degrees east of the Greenwich meridian. So we have this. The Greenwich meridian, 45 degrees, the longitude, and of course we have the latitude. So the point of intersection, like we've said previously, is defining the position of that point E. So we have this point. And then the other position is a position F that is defined by also longitude 45 degrees east, but latitude what? 25 degrees south. So the point of intersection of those two imaginary lines also define the position, the location of a point F. So we have position E here and we have position F here. What's our interest? We are concerned with finding the angular distance between the two. So if from this point, this is drawn to the center of the circle, and then this one is also drawn to the center of the circle. So we have a minor arc EF. Okay, so that arc is now subtending this angle. So the magnitude of what we have here defines the angular difference between the two places on the Earth's surface. So that's what we have. That's what we have. Okay, this is 30 degree. This position is 30 degree north of the equator, and then we have this one 25 degree. You know, this is the equator, so this one moves 25 degree south of the equator. This position moves 30 degree north of the equator. So by the time we deal with this arc, so we just do what? Add the two angles together, and so that gives us what? That of course will give us 55 degrees. So we calculate the angular difference as follows. The angle EOF is equal to angle EOM plus angle MOF, just as shown in that diagram. So that gives us what? 30 plus 25, which is equal to what? 55 degrees. So that defines the angular difference between the two places E and F on the Earth's surface. Okay, so we have the other one. That is the two positions G and H. The two positions G and H. So let's look at them. All right, so again, you come up with your sketch, okay, of what the globe is like. Again, you indicate your polar axis, that's your Greenwich meridian, and then we'll go ahead by trying to locate these positions on the Earth's surface. Okay, so G is defined by the latitude 70 degree north. So 70 degree north. So where we put them, you know, it says it's north. So we have the equator somewhere here. So the latitude will show where to draw the line. So if it's north of the equator, we go up, and if it's south of the equator, we come down. So this is north of the equator, we come up, 70 degree north of the equator. And then what's the longitude? The longitude is 35 degrees west. Okay, that's why we have the longitude 35 degrees. Okay, this one is showing what the longitude is, 35 degree west. That's the longitude. Okay, now the position H is on it's also on the north. Okay, so we have a 40 degree north. So then angle 40 degree north, and then also on the same longitude, 35 degree west. Okay, so how do we deal with that? This one drawn to the center. So this is position G, and of course this is the position H. So the angle that this one is making from here, okay, if you draw this one to the center, you have this angle here, and if you draw H also to the center, you have this small angle here, such that if we intend actually to find the angular difference, then we have to deal with this. All right, so what do we do? So now this is schematic diagram of what we actually have there. Okay, so this is position G, and of course this is position H, and then this point is the equator. Okay, and then when you look at this, the angle you have from here is 90 degrees. So G moves 70 degrees up the equator, and H moves 40 degrees up the equator. So if you want to find the angular difference now, so you have to critically look at the fact that this 40 degree that H moved up is still within the arc of 70 degrees that G moves up. So that tells us that the angular difference between the two will have to be this 70 degree less this 40 degrees, such that the angular difference will be defined by what we have here. So if from here to here is 40 degrees, and the whole of this arc is giving us 70 degrees, that means the distance from H to G will be this, which will be what? 70 less 40 degrees, and that will give us 30 degrees. So we say the angular difference GOH, that's angle GOH, is equal to GOM minus HOM. What we are saying in essence is just that the angle subtended by G is subtracted from the angle subtended by H. So we have 70 degrees minus 40 degrees, and that gives us, of course, 30 degrees. So that's the angular difference between the two positions. So in general, when positions are on the same side of the equator, so what we do, because if you look at the example that we just deal with, if we have positions on the same side of the equator, so what we do is what? We subtract their whether latitude or longitude, as the case may be, from each other. And when we have them on either side of the equator or on either side of the Greenwich meridian, as the case may be, what we do is we add them together. So that's why I've given us this simple analysis. When they are on the same side, you subtract the angles from each other, and when they are on opposite side, that is on divided side of the equator or Greenwich meridian, you do what? You do addition. So we say that this rule also applies. That's what the case for longitude. This rule also applies for latitude differences. Okay, so that rule applies whether you are dealing with longitude or you are dealing with latitude. All right, so I hope that is taken. All right, now, so apart from that, let's quickly look at angular distance on the same latitude. We've looked at angular difference. And we said the angular difference will help us in determining the distances between two positions on the Earth's surface. So we want to look at angular distance on the same latitude. So we look at this example. Now this one is asking us again to find the angular difference actually between the following pairs of points on the Earth's surface. Okay, you have A, 40 degree north, 35 degree west, and B, 40 degree north and 50 degree east. And then we have another point, C, 30 degree south, 20 degree east, and D, 30 degree south and 60 degree east. So how do we deal with that? Solution. Now, the first point, we have point A, 40 degree north, 35 degree west. So that's the latitude now. The latitude. And then we have the longitude as 35 degree west. And then we have another point B. This one is on the same latitude. Okay? Now, the previous example we took, they were on the same longitude, different latitude. But now, the two of them are on the same latitude, different longitude. So, how do we go about this? So, if we look at this, we notice that A and B, they are on opposite sides of the Greenwich meridian, because this one is west of the Greenwich meridian, this one is on the east side of the Greenwich meridian. And from what I've told us, I said when they are on different sides of the Greenwich meridian, the angular difference is calculated by doing what? By doing what? God bless you, by adding the two of them together. So it's when they are on the same side that you go ahead to subtract. So A and B are on the opposite sides of the Greenwich meridian, and as a result, the angular difference is calculated as follows. Because they are on different sides of the Greenwich meridian, so we just go ahead by saying 35 plus 50 degrees. That go ahead to give us 85 degrees. And then the other one, we have point C, 30 degrees south, 20 degrees east, and point D, 30 degrees south, 60 degrees. Now, if you look at this, of course, they are also on the same latitude, but they are on different longitude. But if you take a look at the longitude, they are of different longitude, but of course, they are on the same side. They are on the same side of the Greenwich meridian. So, like I told us earlier, when they are on the same side, what do you do in finding the angular difference? What do you do? Good, you subtract. So, because they are on the same side of the Greenwich meridian, you subtract their longitudes from each other to get the angular difference. So, because we say C and D now are on the same side of the Greenwich meridian, therefore their angular difference is what? 60 minus 20, and that gives us 40 degrees. That gives us 40 degrees. So today we have been able to look at how to determine the angular differences between two places on the Earth's surface, either when they are on the same longitude and different latitude, or whether they are on the same latitudes but different longitudes. And again, you keep in mind I told us that when you are finding angular differences, when suppose they are on different longitudes, now the angular difference is obtained if the two places are on the same side of the Greenwich meridian. When they are on the same side of the Greenwich meridian, it told us that what you need to do to obtain the angular difference is to subtract the angles obtained by each one of them. So you subtract from each other where they are on the same side of the Greenwich meridian. And when they are on either side of the Greenwich meridian, what you do is to do what? You add the two of them together. So the same thing applies to when you have the same latitude and different latitudes. Okay, so when the positions are having latitudes on the same side of the equator, when they're on the same side of the equator, you do what? You subtract the angles obtained from each other. And then when they are on either side of the equator, in finding the angular difference, what you have to do is to simply add the two angles subtended together, and that will give us the angular differences between two places on the different positions on the Earth's surface. Okay, so before we go today, take a look at these questions and try to lay your hand on them. They are very simple enough. You are to find the angular difference between the following pairs of places on the Earth's surface. So, what are those places and what's their coordinates? Let's have them. The first one, you have a position R, that is a 35 degree north, that's the latitude, and then 40 degree east. And then we have a position T, that is on the latitude 25 degrees south, and then on longitude 40 degrees. So this is a simple one. They are on the same longitude, but they are on different latitude. And when you look at the latitude, they are on either side of the equator. So you know how to deal with that, okay? And then, of course, the second one, you have position Q, 40 degree north of the equator and 30 degree west of the Greenwich meridian. And then under position R, also on the latitude 40° north and longitude 50° east of the Greenwich meridian. So you have a case of the same latitude here on a different longitude, and then when you look at the longitude also, they are on either side of the Greenwich meridian. So I'm not to tell you, you know of course what to do with that. So when you're done with that, and perhaps you run into any problem trying to solve some other questions, you can always of course send your problems, your answers, and then whatever comments you have to the address you have at the bottom of your screen, and justice will be done to them on fresh episodes. So that's the point I will be leaving you for now. I hope of course to see you soonest on the next episode. Thank you for now, and have a wonderful time solving those problems. Bye for now.